All right, so I haven't seen this movie in a long time, and I know the Double Dragon is basically, and it's Double Dragon, it came out in 94, and I know that's basically yin and yang, so I decided to start paying close attention to this movie because it's so cheap. It only like took $6 million, and they even lose money, lost money on it. But this right here is actually 434 plus 232 equals 666. Now this right here, I'm just go ahead and throw this out. Okay, so this says the energy something. This definitely says magnetic pattern. Anyway, the magnetic pattern I'm seeing is that this right here is basically the singularity, which was a macro neutron star. And a neutron star is also a magnetar. Magnetars have really, really intense magnetic fields, like the snake or the dragons, yin and yang, which was basically the Orphic egg or phanes or the world egg. This is the magnetic field, the singularity. Caduceus, the hospital insignia. Auryn, a never-ending story. And of course, Mum-Ra, his insignia. And these are the two dragons here. These are yin and these are yang. And this was the singularity. Think of particles like star physics, just how they would composite. Like one represents the dark, one's the light. There's definitely a 6 right here and a 9 right there. 6 and 9 is yin and yang. 6 times 9 is 54. Note that this stuff is Asian. It's Taoism. It's basically their version of esoteric stuff, the flower of life kind of stuff. There's 54 cards in a deck. Now there's 52 usable, but 54 total. 2 jokers, yin and yang. 52 weeks in a year. In the 6 and 9 yin and yang, there's 2 major arms, or 2 dominating arms in the Milky Way. But there's 8 total arms. The other small arms are clustered around these 2 main branches. 6 times 6 times 6 is 216. The moon's diameter is 2160. Now you type in 2160, you get 4K resolution. Well, we're not there. We're not talking about that right now. Which that does tie into it in computers and the universe and all that and mirrors. So it divides by 3, by 6, which is a 360, and 9, which is 240, as in a 24-hour day, but on a larger scale. Now Earth spins 1,000 miles per hour. There's 1,000 micrometers in 1 millimeter. There's 25.4 millimeters in 1 inch. And 1 inch is 2.54 centimeters. Our circumference is 25,000 miles around. I'm just getting the basis of our measurements. This is why they fit together. Note that all these numbers are really close, but they're on different scales. But the problem with the galactic year is they have it at 225 instead of 250, which is technically 250 million years. That would be a full rotation, like a clock on a larger scale. That's why our Milky Way is technically 54 galactic years old. The 6 times 9 is 54, squaring the circle. Yin and yang, factors of 3, 6, 9. The sun is technically 864 miles in diameter. And 864 times 2.5 is 2160. There's that 2.5 or 25 again. So a galactic year is technically 250 million years for us to go all the way around. Even here they have about 230 million years. So it's a couple different things. But when you square the circle with the 369 method, it's 250 million years. All that was space-wise, distance-wise, measurement. This right here is time-wise. 1 second is 1,000 milliseconds. Now that would be analogous to the 1,000 mile per hour spin, meaning on a macro scale, 1 second is 1 day. 1 full rotation is 1 second. Another full rotation is 2 seconds. Another full rotation is 3 seconds until you get the precess, a full macrocosmic day, 1 full day. And a precession is 25,772, or roughly anywhere from 25,000 to 26,000. There's that number again. Now, all this ties to arc seconds and minutes of arc, but it's not necessarily the exact same thing. It is, but it isn't. See, an arc minute here is 21, that's 1 of 21,600, because 1 degree is 1/360th. Now, in a full arc circle, there's 1296 here. On this scale, it's over 1.2 million. And this ties into the BGA socket 1296, which is computers. And this ties into this space and the computers ties in the same reason why I typed in 2160, which is the diameter of the moon, and it comes up screen resolution. The same reason our platonic solids show up in our video games. Like, say, for example, this Radon HD 7770. These have pixel and vertex shaders. Shade these vertices, and the more shaders you have, the more precision you can get out of your polygonal video games. So everybody remembers the old school stuff. These are all sprites, which is basically kind of like a GIF. It's a series of just 2-dimensional renditions strung together. You can just control them. I mean, remember the original PlayStation? I mean, it did 90,000 polygons per second with texture mapping, lighting, garage shading, 180, which is half of 360, with texture mapping, and 360,000 with flat shading, three-dimensional. And these were badass graphics back in the day, but remember how grainy it was? And how boxy, real pointy here? Now, this is the Nintendo 64. They have a bilinear filtering. The PlayStation didn't do that. And that's what made the Nintendo 64 really unique, the bilinear filtering and the trilinear filtering. If you had the increased megabyte little slot, you stick in the little slot. They made games designed for that little memory module. Of course, this is all known as basically a graphical interface. Like this, it's a graphical interface, just like this. It's holographic. It's a graphical user interface. It's hollow because it's got a lot of space in it. It's graphical because it's a light imagery, but it's not technically a holograph. It's real. It suits all of the... It satisfies the term holograph, other than the fact that it's actually real. And that's why we have the simulation theory. I'm just kind of touching on all kinds of stuff, help people kind of connect some dots, that's all. And you can divide 2160 by 8, which gives you 27 or 270, 999. Meaning that 2160 divides by 3, 6, 9, and 8 evenly. Like on this, the significance of the 8, like here, 8 times 8 is 64, 640 shading units. Like here's 80 gigaflops. The 16 is 8 times 2. That's its gigapixels, or pixel rate. 80 watts, you know, and it's got the 25 here for 250 watt suggested PSU, power supply unit. Of course, the power supply in the computer is 12 volts, which is basically half a day. That's why motherboards look like the pyramid complex. And the pyramid complex ties to the stars. See, it's all a big circle. We just reinvent the same kind of technology in different ways. And that's why technically this is a combustion chamber where fusion was taking place, or flux with the Ark of the Covenant. And these were valves, input-output shafts, like your input-output. Your timing is everything in your car. If the timing is off, it won't work at all. And of course, time applies to the stars, timing, the pyramids, computers, the moon, the sun. It's all the same. I mean, that's why they're called microstar, probably. Of course, we name our cars after space. Nissan Pulsar, the Saturn, the Solara. And these are just 3. And there's a lot of universe cars out there. Even the Comet. That's why a car ignition system technically runs on 12 volts. And it actually mirrors the complex. Of course, computer power supply is 12 volts also. That's half of our technology. Then the AC current is 120 volts. 12, again, just 12 times 10. The 10 in this aspect is the 1000 was earlier.